Today we're going to be learning about simplifying radicals. I know you guys are really excited about that, so let's get to it. Okay, the product property of radicals. Here I have the nth root of x times y is equal to the nth root of x times the nth root of y. And I know that looks like total gibberish right now, but basically what we're doing is we are separating these factors and keeping that nth root. So n meaning any number, could be square, could be cube root, fourth root, whatever. We're going to keep the root and we're just separating the factors. Let's see this in action. Our first example, A, has the square root of 24. The first thing I want to do is find out what are my factors of 24. And the easiest way to do that is to do prime factorization. Let's split it up. Here we go. Square root of 2 times 2 times 2 times 3. And what I'm going to do is find the doubles. The reason why I'm looking for doubles is because when I square root 2 times 2, 2 times 2 is 4, the square root of 4 is 2. So I'm going to find my doubles and I'm going to complete the operation, in this case square root it, and then I'm going to throw it outside of my radical. Okay, here's our first set of 2's. I'm going to take the square root of 2 times 2, which is just 2, and I'm throwing it out. Let's simplify. Okay, now I have 2 outside of the radical sign and 6 left on the inside. How I got 6, I multiplied that 2 and 3 that were left in the radicand, and that gave us the 6. Let's look at our next example. I have the square root of 75. Again, I'm going to use prime factorization to get the factors of that. So I have 3 times 5 times 5. Again, looking for doubles. Do you see it? There it is. Okay, I have my double. The square root of 5 times 5 is just 5, and I'm going to throw it out and rewrite it. There we go. 5 times the square root of 3. Nothing to multiply in the radicand there. Now I have the cube root of 40. Do not be alarmed. We are using the same process. The cube root of 40, we're looking, instead of pairs, I'm looking for triple. Okay, I want 3 guys. Let's see what we have here. I have used prime factorization to see that it is 2 times 2 times 2 times 5. I'm going to find my 3 equal factors, which are my 2's right over here. The cube root of 2 cubed is just 2. So I'm throwing that outside of my radical sign, and when I simplify, I'm just left with 2 times the cube root of 5. Let's look at some steps that you can write down. We have your first step. Write the radicand as the product of its prime factors. So I hope you have your notes in a pencil, or you type it up, or whatever it is that you're doing. Make sure you have these steps. So writing the radicand is that first step. We did that in the previous slide with the prime factors. Your next step is to apply the product property to perfect powers. And we're going to see that more in the next example, but keep it in mind. Then we're going to simplify the roots of the perfect squares. And our next step is to multiply the factors inside and outside of the radical. We did a little bit of that in the previous slide as well. Let's practice. I have to warn you though, I have some big numbers on the next slide. Do not freak out. You can do it. Are you ready? Boom. There's your big numbers, but I promise you, you can do it. You're going to start by doing the prime factorization. You're going to divide by 2 until it is not divisible by 2 anymore, then divide by 3 until that's no longer divisible, and you're going to keep on going until this is in prime factors. Okay, I have listed the prime factors already, and now we are looking for, well, since we're squaring it, we are needing doubles. Okay, let's find doubles. Do you see them? Here's 1. Taking the square root of 2 times 2, that's just 2. Throw them out. There's another double, 3 times 3. Throw them out. And let's find one more double. There we go. I got a little lazy with that arrow, but you get it, right? Just throw them out. Okay. Now I just need to simplify. So outside of my radical sign, I have 2 times 3 times 3. And then what was left under the radical sign, just that lonely 2 that I did not circle. So our next step was to simplify, right? We need to multiply the terms inside and outside of the radical. It doesn't look like there's anything to multiply inside of the radical, so I'm just looking at outside of the radical. 2 times 3 is 6, 6 times 3 is 18. There we go. Let's look at our next problem. I have the cube root of 14,580. What? Okay, so cube root means I am looking for 3 equal factors. Let's break this baby up and see what we can find. Boom. Okay, lots of numbers. We can still do it. Now it's just a matter of finding those 3 equal numbers, okay? 3. I cannot emphasize that enough. Let's find groups of 3. There's 1, and there's 2, and that's it. So the cube root of 3 times 3 times 3 is just 3. I'm completing the operation, and I'm throwing 1 3 out of the radical sign. So I have 3 times 3, okay? We have the 1 that came from that group, the other 3 came from the second group, and then what is left in the radicand? We have 5 and 2 times 2. Okay, you need to multiply them back together to have one number under the radicand. So 5 times 2 is 10, 10 times 2 is 20. So that is where that 20 came from. I still need to simplify by multiplying those numbers outside of the radical sign. 3 times 3 is 9. Good job. So now I have 9 times the cube root of 20. Now we are looking at the nth root of x to the n power. What does that even mean? It means they are inverse operations. They undo each other. Just like adding and subtracting, or multiplying and dividing. Okay, the nth root of x to the n power is just canceling each other out. Notice that they are the same. Okay, if this was the square root of x squared, would just be x. But the problem, not really a problem, but what we need to consider, like our previous lesson where we had 4 times 4 is 16 and negative 4 times negative 4 is 16, I don't know if x is positive or negative, because either way I'm getting a positive answer. So to ensure that I'm getting a positive answer with this variable, I'm going to put my absolute value signs on it so I know it is positive. This is only necessary when I'm taking the nth root of x to the n power and n is even. Even numbers, 2, 4, 6, 8. Who do we appreciate? Just kidding. Totally ignore that. Sorry. That is for even numbers. If n is an odd number, if this is the cube root of x cubed, you do not need those absolute values, because if it's negative, if x is negative, then you're going to get a negative number. If it's positive, you're going to get a positive number. So again, that was relating to the previous lesson. Let's see how this works in a problem. I have the square root of 32 times x cubed times y squared. So I'm going to split it up. There we go. So why did I not break 16 down? The reason why I did not put 16 into prime factors is because 16 is a perfect square. Why do I want to expand it when I know what the square root of 16 is? I know it. We're good. Okay, so I broke this up so I can find perfect squares easier. So you see how I had x cubed, I had 3 x's basically, that's x times x times x. I put 2 together because that's a perfect square, put them to one side, and left the extra x on its own. Okay, I just separated them. So here's a perfect square, there's a perfect square, and there is a perfect square. Now I'm going to split them up, just like we did in the earlier slide where we had the product property of radicals. I'm going to keep the square root sign, but I'm going to separate my factors. Are you ready? That's what it looks like. I know. But now I can do the square root of 16, which we know is 4, times the square root of 2x, which is just the square root of 2x. And then here I have the square root of x squared. So according to my little rule up on top of this slide, I have to do the absolute value of x. And then the same goes for square root of y squared. Because the root is even, they do undo each other, but I'm going to say this the absolute value of y. So here we go. We wrote it out. 4 times absolute value of x times absolute value of y times the square root of 2x. I will let you know that the square root of x actually does not have to stay, not the square root, the absolute value, just kidding. So the absolute value signs do not have to stay there because it was originally x cubed, and since x was positive there, it will continue to be positive. Ooh, something just bit me. Okay, let's look at more practice. This is our last one for today. Anyway, the cube root of 16 times x squared times y to the 4th power times z to the 6th power. Sounds like a lot, but we're going to use the same processes that we've been learning throughout this lesson. I'm going to factor this. Let's do it. Boom. Okay, why did I not break 8 down into prime factors? Because it is a perfect cube. Hello, it's 2 times 2 times 2. Why am I going to mess that up? I'm just going to leave it as 8. There we go. So that's a perfect square, perfect cube right there. There's not really anything I can do with x squared since I'm looking for groups of 3. However, I see with my y's, I had 4 y's. I'm going to put 3 over here and 1 over there. So that way I can take the cube root very easily. And then I split up my 6 z's as well. I have one group of 3 here, one group of 3 there. And then I'm going to break up my square root. Okay, let's see how that looks like. Ready? And boom, look at that. That's like a million bazillion of these things. That's what it feels like anyway, but we're going to look at each individual term here and just complete the operation. So we have the cube root of 8, which I said earlier, that is 2. Okay, then the cube root of 2, I don't know, I'm just going to leave that alone. Then the cube root of x squared, I'm also going to leave that alone. And then a cube root of y cubed. Well, we know from our previous slide that that cancels, right? They are inverse operations, and it is just y, and a positive y at that, since it is an odd root. We also have the cube root of plain y, which is, I'm just going to leave that alone for a minute. And then we have the cube root of z cubed twice. So those are inverse operations. They're going to cancel, and you're going to be left with z. So basically, outside of my radical sign, I'm going to see 2 from that 8, and I'm going to see a y, and I'm going to see a z and another z. So what's left behind, I have 2 x squared and y. We're going to stick them back together under one radical sign. Okay, let's put them back. So outside of that radical sign, again, I have 2 times y times z, and then I have the cube root of the other guys. Okay, they were left over. I know, kind of sad. I feel bad for them too. Can we simplify this anymore? Yeah, we can simplify it more. I see those two z's over here. Look at them. Look at them. How else can I write those two z's? How about z squared? There you go. You got it. It is simplified. Awesome. So thank you so much for watching the video. I hope that helped, and I hope you guys took notes as needed, and I hope you have a very blessed day.